The very first unit we did this year in this class was over matrices. So the first 10 questions on the midterm are going to be about matrices. Simplify the following expressions. If they cannot be performed, write undefined. All right, number 1. They're wanting you to subtract the matrices. Well, first you have to decide, can I subtract them? So to know that, you have to look at the dimensions. Remember, dimensions are done as rows by columns. Okay, rows are horizontal and columns are vertical. The best way I can help you remember that is to think about columns on a house. You know the big white poles on the front of some big houses? Okay, those are called columns. Not just the White House though. I mean, there's houses around here with big white columns. Okay, so rows are horizontal, columns are vertical. So, what are the dimensions of this matrix? 2 by 1. There's 2 rows, 2 horizontal lines of elements, 1 column. Now, is there a special name for a matrix that has 1 column? Column matrix. So this is an example of a column matrix, as is this one, because this one's also a 2 by 1. Now, oops, I wrote 2 by 2. Since they are identical, both being 2 by 1, that means yes, we can subtract them, and your answer will also be a 2 by 1. Okay, when you subtract corresponding elements, like 4 and 8 are corresponding because they're in the same location. 4 minus 8 is negative 4. Negative 2 minus negative 7. Say that you have trouble when doing something like negative 2 minus negative 7. Take the time to punch it in. Negative 2 minus negative 7. 5. Okay? Now, say that you don't want to do any of that by hand and you want to do the entire problem in the calculator. Let me show you how that's done. You would hit alpha, zoom. This is a 2 by 1, so you have to set it up. Okay, 2 rows, 1 column. Pay attention. Okay, it sets it up for you, and then you just have to enter the 2 elements, 4 and negative 2. Then make sure you arrow outside of it before hitting the subtract sign. And now go back to alpha zoom to set up your next 2 by 1 matrix. 8 and negative 7 are its elements. And then when you hit enter, it gives you the exact same answer we got when we did it by hand. Now, I think it's easier to do it by hand instead of wasting all your time typing it in. Okay? I think it's way easier to just do this by hand. However, there are some of you who really struggle with negatives, and I'm afraid you might put like negative 2 minus negative 7 equals negative 9 or something. Okay, so if you really struggle with negatives, type it in. Okay? Alright, now let's look at the next problem. They want us to subtract those matrices. Can we?
Yes.
Yes, because they're both what dimensions?
2 by 2.
Right. What do we call a matrix when the rows and the columns match?
Square.
A square matrix. Okay? Our answer is also going to be a square matrix. Okay, now you subtract the corresponding elements. So like negative 2 corresponds to negative 4. So say you're doing it by hand. Say you're not taking the time to use alpha zoom and type in the whole matrix, but you at least want to type in the negative 2 minus negative 4. That's okay. Negative 2 minus negative 4 is positive 2. So this element is positive 2. Now the next one is just 10 minus 0. You won't have to use your calculator for that. The next one is 0 minus a negative 2. You might want to type it in. 0 minus negative 2. Just depending on how strong you are with adding and subtracting negatives. And then 6 minus 1, nobody should have to type that in. 5. Okay, so that's your answer. Now, if you wanted to type in the whole thing using alpha zoom, that's also fine as well. Okay, number 3. This time they're wanting you to add. Can we add them? Yes. What are the dimensions of this matrix? 1 by 3. It has 1 horizontal line of data and 3 vertical. So it's a 1 by 3. Is there a special name for that type of matrix? A row matrix. Okay? If this is a column matrix with 1 column, then a matrix with 1 row is a row matrix. These dimensions are also 1 by 3. So that means we can add them. You can take the time to Zoom and type in each one and add them, but it's really easier just to do it by hand. 0 plus 15 is 15. 11 plus 7 is 18. Negative 9 plus negative 3. Say you're not sure, you use the calculator. Negative 9 plus negative 3. Okay, don't get something wrong like that because you were too lazy to pick up the calculator. Okay, if you're not absolutely sure that negative 9 plus negative 3 is negative 12, then you should type it in. Okay, do not just guess. All right, number 4. This time, what do they want you to do to this matrix? Multiply. Does anybody remember what this negative 3 is called? It starts with an S. No. Scalar. Scalar. Okay, and all you do is multiply each element inside this 2 by 1 matrix with the scalar of negative 3. Now our answer will still remain a 2 by 1. The scalar doesn't change the dimensions. It just makes a 10 become a negative 30 and 0 stay 0. Okay, number 5. What are they wanting you to do in problem number 5?
Multiply.
Multiply. Okay, we did learn how to multiply by hand, but it's a lot to remember. So for that reason, we will use Alpha Zoom for this. Now, before you type it all in though, let's make sure it can be multiplied. What are the dimensions of this matrix?
2 by 2.
2 by 2. And what about this one? 2 by 1. 2 rows, 1 column. So can they be multiplied?
Yeah.
Yes, it's different than adding and subtracting. Right, when adding and subtracting, they have to be completely identical, like everything the same. But when multiplying, only the 2 inside dimensions have to match. Now, the outside dimensions are also helpful. This 2 and this 1 let you know that your answer is going to be a 2 by 1. Okay, but now let's type it in to get the 2 elements of that answer. So, Alpha Zoom, our first matrix is a 2 by 2. Okay, and the elements are negative 6, okay, then we're going to multiply that by this matrix, which is a 2 by 1. Okay, and its elements are 1 and 3. And then once you hit enter, it gives you your answer, 3, negative 13. Okay, any questions so far? All right, number 6, evaluate the determinant. I'll go over both ways, by hand and with the calculator. To evaluate the determinant by hand, the formula is A times B minus B times C. But to be able to use that formula, you also have to know that with a 2 by 2 matrix, it's in the form A, B, C, D. Okay, so to be able to use this, you have to know this. So when you multiply the A times the D over here, what do you get? 20. Because look, your A is 10, your D is 2, 10 times 2 is 20. And then minus is part of the formula. What do you get when you do the B times the C? Negative 21, and a 20 minus negative 21 is like a 20 plus 21, which is 41. Okay, now say you don't think you can remember this formula. You can use the calculator. Everybody look, so you'll see the buttons I'm pressing.
I know.
Second matrix. See where it says matrix right there? And that's why we had to hit second, because it's above. Go over to math and look at the very first option, determinant. Once you pull that up on your screen, you use Alpha Zoom and you type in the matrix. So we're dealing with a 2 by 2. Hold on one second. And its elements are 10, 7, negative 3, and positive 2. And then you just hit enter and we get 41, just like we got when we did it by hand. So whatever works better for you, AD minus BC, or remembering to do second matrix, go over to math and punch determinant and then type in the matrix. Okay, whatever is easier for you to remember. But it's complicated. I'll show you the formula, but we're going to do it with the calculator. Remember, the formula for inverse, you had to do 1 divided by the determinant. So first you had to figure out the determinant. And then you did 1 divided by it, and then you multiplied that by this crazy matrix where you switched the A and B, and you switch the signs on the B and C. Y'all remember that? How you did 1 divided by the determinant times that crazy matrix?
Yeah.
Well, there's no sense in wasting your time doing that when the calculator will do it for you with one button. Okay, so first we're going to type in the original matrix. So we use alpha zoom. Okay, so we're dealing with a 2 by 2. Its elements are 11, negative 5. Oops, what did I do? I somehow got out of it there. 2 and negative 1. Now, instead of going through all the trouble of 1 divided by the determinant times the crazy matrix, this is all you have to do. See this button over here that says x to the negative 1? You press it, and that one button is doing all of that for you. When you hit that one button and hit enter, it does the 1 over the determinant times the crazy matrix for you, and you end up with 1, negative 5, 1, negative 5, 2, negative 11. Okay, and that's the inverse. Let's continue. Number 8, solve each system using matrices. Okay, this is where you have to set it up. You have to make a coefficient matrix. What is a coefficient? The number beside the variable. So like 4 is a coefficient, negative 5, negative 3, and positive 4. And see how the two coefficients that were with the x's are lined up and the two coefficients with the y's are lined up? You have to line those up like that. Then you also make a matrix with what is equal to, negative 13 and negative 10. Now, to figure out what x equals and what y equals, you're going to type this matrix in and take the inverse of it. And then you're going to multiply it by this matrix. Okay? So let's do that. First I have to type in this 2 by 2. So alpha zoom. The elements are 4, negative 5. Alpha zoom, 4, negative 5, negative 3, and 4. And then I take the inverse of that, and then I multiply it by this matrix. So I have to go back to alpha zoom, but this time it's a 2 by 1. Okay, and then we have negative 13 and negative 10. Okay, so we all got negative 102 and negative 79. Okay, so now let's try this one. This time we don't just have x and y to solve for, we have x, y, and z. So for that reason, we're going to have a 3 by 3 matrix with 9 elements. What are the first 3 elements? 2, 1, negative 1. Okay, what about the second row? 3, 0, 1. Does everybody understand where the 0 comes from? Because look, in this line, in this equation, the x skipped straight to the z. The y got missed, or it got skipped over. That must have meant that it was plus 0y. And then plus 1, 0. So 3, 0, 1. And then what's the last row?
5, 2.
Right. Okay, so that's our coefficient matrix, so we're going to take the inverse of it. And then we're going to multiply it by this matrix with the constants. 3, negative 5, positive 5. Okay, y'all go ahead and type that in and figure out what x, y, and z equal. Again, what did you get for x?
Negative 1.
What did you get for y?
3.
And z?
Negative 2.
Okay, let's talk about what those numbers mean. Look up here. 2x plus y minus z equals 3. And we're saying that x is negative 1, y is 3, and z is negative 2. Type that in. Type in 2 times negative 1 plus 3 minus negative 2. So see how it actually actually equal 3 like it said? If
Yeah.
you typed in -1 here and -2 into the z, you would get -5. If you typed in -1, +3, -2, you would get +5. That's why those are the solutions. When plugged in, they make it equal those 3 values. Same thing over here. If we'd have typed in a 4 times a -102 minus 5 times a -79, it would have equaled -13. Okay, now flip to the next page. Alright, how many edges are represented by the following adjacency matrix and draw the vertex edge graph?
11 edges.
Okay, the vertex edge graph, first you need to plot points. How many points do we need? 5, because there's 5 letters. So, it doesn't really matter how you do it. A, B, C, D, E. Okay, now we're going to go through and we're going to connect. What lets you know what connections to make? Right, like the ones let you know what connects. Okay, so like A doesn't connect to itself, obviously. A doesn't connect to B. But A does connect to C, D, and E. So we need to draw a line from A to C, A to D, and A to E. B doesn't connect to A or B or D, but it connects to C and E. So B to C and B to E. C connects to A and B. A, B, those were already done for us. And C connects to D. D connects to A, which is already done. D connects to C, which is already done. E connects to A, already done. D connects to B, already done. So, how many total edges did we end up with? 1, 2, 3, 4, 5, 6. Now, say that on the midterm next week, they're not asking you to actually do the vertex edge graph. They just give you this matrix and ask how many edges. What's a faster way to do it if you don't want to draw the picture?
Well, count the ones.
Count the ones. How many ones are there? And divide it by 2. And why exactly are we dividing it by 2? Because they get counted twice. Like A connected to C up here, but then down there C to A, but that's the same edge. A to C, C to A is one edge. It gets counted twice. That's why you divide it by 2. Earlier in 3rd period, one girl said she does it like this. She connects the ones. There's a connection, but see, since those are used, you can't use them again. Here's a connection, here's a connection, here's one, and here's one, and then she just said I count 6 edges. So that's an easy way to do it too. Okay, now, so we're done reviewing matrices. Now on to Unit 2, functions. Write a function that would represent the following relationships. To be quadratic, what degree does it have to be? Squared, degree 2. And then it can have a lot of other stuff, but it has to have an x squared. It might have like x squared plus 5 or x squared plus x minus 3. But it has to be degree 2. What about linear? X to the first, which y equals mx plus b. But in this y equals mx plus b because it's like 1x plus 0. Okay, exponential. What does that mean? That's cubic. Yeah, exponential is the hardest one for people to remember. It's when the x is the exponent. Okay, think about it. Exponential exponent is when your variable is your exponent. Alright, the next section, they want you to look at the 2 functions provided, and first they want you to add them. So first we'll look at the f function and add it to the g function. What is the f function? 3x minus 2. What's the g function? Okay, once you set it up, what do? Just combine like terms by adding, right? What's 3x plus 7x? 10x. What's negative 2 plus 3? Positive 1. So that's your answer. Okay, when we get back from lunch, we're finishing 3 through 10, so there's no cell phones. You need to come in quietly, ready to finish this section. Okay? All right, number 3. This time they want you to find f minus g of x. So they want you to take the f function, which is 3x minus 2, and subtract the g function, which is 7x plus 3. But what makes subtracting a little more difficult than adding?
You have to drop the sign.
Right. You have to distribute this negative out because just combine like terms. 3x minus 7x is negative 4x. Negative 2 minus 3 is negative 5. And then that's your final answer.
I got that.
Okay. Number 4.
That was fun.
This time they want you to take those same two functions, f of x, which is 3x minus 2, and g of x, which is 7x plus 3, and they want you to multiply them. So now that I've set it up, what word pops in your head? FOIL. So 3x times 7x is 21x squared. 3x times 3 is positive 9x. Negative 2 times 7x is negative 14x. And negative 2 times 3 is negative 6. Then we see that 9x and negative 14x can be combined to a negative 5x. And then just drop down the x squared term and the constant. What kind of polynomial is this?
It's a tron.
What kind of trinomial?
Squared.
No, it's a
Quadratic.
Yeah,
Quadratic
quadratic trinomial.
Degree 2 trinomial because it's 3 terms. Okay, can I erase?
Yes.
Okay, I'm erasing unless...
I got that one right.
Alright, number 5. Okay, this time we have g of f of 3 if f of x equals x squared and g of x equals 2x minus 6. Okay, so what do they want you to do first? Right, see how 3 is seated right next to the f? That means they want you to go to this f function and replace the x with a 3. Well, when you do that, what do you get? So now you have g of 9. So now you would plug 9 in the g function, which is 2x minus 6. So we replaced its x with a 9, and what does that give us? 12. And so that's the final answer. Oh, that's fine. Yeah, that's fine. Okay, now turn to the next page. Number 6, describe what happens to the graph of f of x if it becomes f of x minus 7. So if you have a function, any function, and you put minus 7 on the end of the equation, what does it do?
Down.
Moves it down 7. Remember we talked about this when we were working on this unit? 7 is an outside number. It's outside of the parentheses. Outside numbers move the graph up and down. Okay, so plus 7 on the outside would be up 7. Minus 7 on the outside would be down 7. This is considered an inside number. And inside numbers move it left or right. Okay, and it's not what you would think. X plus 6 moves it left 6. It's the opposite of what you would think. Plus 6 moves it to the left. Minus 6 would have moved it to the right. Just remember that outside numbers, the numbers that are outside of the parentheses, move it up or down. And they are what you would think. Plus would move it up, minus moves it down. But inside numbers, the numbers inside parentheses with the x, move it left or right, and they're the opposite. Plus is left, minus would be right. Now, this is a number out in front of the function. What does that do? Shrink or stretch, and in this case it would be a shrink. If it's less than 1, it's a shrink. If it's greater than 1, it's a stretch. I'm not sure what word will be on there. Okay, number 7. Write an equation that can represent the following graph. Okay, well look at this picture. Tell me what you notice about this graph. There's a parabola, which means it's what kind of equation? Quadratic, which means it's x to the second power. Okay, what else do you notice about it? Up, how many? And what direction over? How many? Okay. It's also opening up, so it's positive. Now, so y equals x right 1. How do you represent right 1? Minus 1. But remember, horizontal shifts go inside parentheses with the x. And then at that point you square it since it's quadratic. And then up 3 would be represented with a plus 3.
They go the same
They
way.
go the same way, and they're symmetric to the y-axis. So like a parabola is an even function, because if it's at 0, 0, or anywhere on the y-axis for that matter, it's symmetric to the y-axis. Also think about it. Aren't parabolas y equals x squared? And isn't 2 an even number? Okay, what about odd functions?
They go opposite directions.
They go opposite ways and are symmetric to the origin. And think about it, that's a cubic function, which is y equals x cubed, and isn't 3 an odd number? Alright, last two questions. Find the inverse of f of x equals 8 minus x. Okay, back when we learned this, I taught you two steps for finding the inverse. Step 1, switch the x and the y. Step 2, solve for y. Okay, so if I go over here and I say step 1, switch the x and the y, where's the y?
It's the.
Right, f of x is y. It's the same thing. One of them's just function notation. So now I need to switch them. What will it look like when I switch them? Correct. Okay, now it says solve for y. How would I start that process? Subtract 8 on both sides. Those cancel, and so now you have x minus 8 equals negative y. So now to solve for y, that's a negative 1, so we divide by it. And you divide everything by it. So we ended up with y equals x divided by negative 1 is negative 8. Negative 8 divided by negative 1 is positive 8. Okay, I'm going to give you about 30-second head start. You try number 10. Step 1 is switch the x and the y. Well, f of x is the same thing as y. So now when I switch them, it'll be x equals 5 plus y divided by 7. Step 2 is solve for y. What is my first step in solving for that y?
Multiply by 7.
Correct. I've got to undo that divided by 7 by multiplying it on both sides. So now I have 7x equals 5 plus y. Now the last step to solve for y is
Subtract by 5.
subtract 5 on both sides. So y equals
7x minus 5.
7x minus 5. And so that's the inverse of that
Yay.
equation.
Got that.